Hello everyone, welcome to your one and only weekly AtCoder Chronicles episode, where today I'll go over the solutions of the first 5 problems of ABC381. I unfortunately had to miss this contest because I didn't notice the date changed to one day earlier, which meant that the contest occurred on the 22nd of November, and the problem setters used the date to their great advantage. The first 6 problems alternately involve 1122 strings or sequences and 11/22 strings, so I'll give the definitions right now. A 1122 string or sequence is where pairs of characters or elements occur adjacently, and no pairs use the same element. So, for example, AABB is a 1122 string, but ABB or AABBAA aren't. A 11/22 string is a string with odd length. The middle character is a slash, all characters before it are 1s, and all characters after it are 2s. So it has the property that they're in equal numbers of 1s and 2s. Now let's begin talking about the problems. Given a string s of length n, determine if s is a 11/22 string. Well, first, if n is even, then that's an instant no. Otherwise, we can look at the middle of the string, then the left and right sides. If either of those 3 sections have something that isn't in the right place, then that's a no, and if everything matches, we print yes. Given a string s, determine if s is a 1122 string. Like the previous problem, we proceed to peruse the parity of the provided string. If odd, then it prevents the possibility of a positive result, per lack of pairs. Otherwise, we check each pair of characters in the string, storing the used one in a map. If they're both the same character, and one that's new, we add it to our map and move on. Otherwise, we print no. After all checks have been passed, print yes. Given a string s of length n, determine the length of the longest contiguous substring of s that is a 11/22 string. Since the substring must be contiguous, that makes our problem much easier. Don't worry though, the not necessarily contiguous case will come in problem E. For now though, since each 11/22 string must contain exactly 1 slash, we can use it to anchor our search. For each occurrence of a slash, we can keep stepping at one's left and right, and if there's a 1 and a 2 at their respective ends, then we can, continue until we can't. Then, the maximum of the lengths that we end up with will be our answer. Given an integer array of length n, determine the maximum length of a contiguous subarray that forms a 1122 subsequence. Well, here we have 2 cases. The subsequence starts from an odd index, like 1 or 3, or an even index, like 2 or 8. I'm using 1 indexing here, as usual. When we're scanning from left to right, we have to keep track of our left endpoint to find the length of our current subarray with our current right endpoint. If our current right index is at i+1, then our length will be i+1 minus l plus 1, which is i+2 minus l. As each element is between 1 and n, and as n is small enough, we can use an array to store the previous position of each element. If we find a new pair, do nothing. If we find a non-pair, reset our progress. If we find a repeated pair, we'll have to move our left endpoint to the right. But there's a subtle trick that I took a while to notice. Say we have the sequence 1122332211. When we reach the second 22, then our left point moves to the first 3. And then, again, when we reach the second 11, as we already moved our left endpoint past the first 11, we don't need to do anything. And so this tells us that we have to take the maximum with the left endpoint whenever we have to shift it. The length calculation is also why I used an array instead of a map to store the last positions. Since we're shifting 2 steps to the right of the last occurrence when we see a pair, when starting at an odd index, we have to set everything to -1 by default so that a new pair would end up at the beginning, which is 1. and setting default values for maps doesn't really exist in C++. Also, for even indexes, we set it to 0, so adding 2 gives us 2 by default. Given a string s of length n and q queries, you're asked the maximum length of a 11/22, not necessarily contiguous, there you go, substring of s within an interval LR, which is given to you for each query. Again, we use the property that a 11/22 string has exactly one slash. So, we want to choose a slash in the interval from L to R such that it maximizes the minimum of the number of 1 characters to the left and the number of 2 characters to the right. Note that when we move the slash character to the right, the number of 1s always increases and the number of 2s always decreases. This points us into using binary search. We can pre-process the string to find the prefix sum of the number of 1s, 2s, and slashes, and also store the indexes of all the slashes for easy use. Whenever we get an interval, we can find the position of the leftmost and rightmost slash in that interval using our prefix sum, and then go inwards until we find the perfect balance point. As we will end up with 2 endpoints using binary search, we can just calculate the answer for both and find the maximum of those. At the end, don't forget to multiply by 2 and add 1 to find the total length of the string, not just the number of 1s or 2s. That's all for this week. Have a good one.